Question 1. A Ferris wheel with a diameter d equals 70.5 meters rotates at a constant speed. The lowest point on the wheel h equals 2.05 meters above the ground, as shown on the following diagram. So this h equals 2.05. P is a point on the wheel. The wheel starts moving with P at the lowest point and completes 1.5 revolution in 2 minutes. The height, h meters of P above the ground after t seconds, is given by h of t equals negative a cosine bt plus c. A, B, C are positive real numbers. When you are given this function, you have to pay more attention to the units. T seconds. H is above the ground. Since we are given this wheel, we could say the midline is here. This is the midline. According to the given information, diameter is 70.5. So radians equals 70.5 over 2, 35.25. From this function, we know A is the amplitude. Amplitude basically is the radius of this wheel. Or you could say the distance from maximum to the midline is amplitude. So A equals 35.25. C is midline. 35.25 plus 2.05 equals 37.3. Calculate the value of period. Let's talk about period. If you are given a function, then period equals 360 over b or 2 pi over b. If you are given a graph, let's label the coordinate for A is x, capital M, and maximum. For B is x, lowercase m, and minimum. Then the period equals 2 times the absolute value of x coordinate at maximum point minus x coordinate at minimum point. In other words, period is double the horizontal distance between two consecutive maximum and minimum point. For third one, word problem. Period equals value of independent variable for a complete revolution. We are given the information here for the period 1.5 revolution in 2 minutes. Remember the unit for time is seconds. So 1.5 in 2 minutes times 60 to get seconds. How much time for one revolution? T equals 120 over 1.5 equals 80. So period equals 80 seconds. B equals 360 over 80 equals 4.5. A ride on the Ferris wheel lasts for 16 minutes in total. Calculate the number of revolutions of the Ferris wheel per ride. 1.5 revolution in 2 minutes. 1.5 over 2 minutes. What's the revolution? Let's use R stand for that. 16 minutes. Then R equals 12 revolutions. Let's go to D. For exactly one ride on the Ferris wheel, suggests an appropriate domain for h of t. Since one ride lasts 16 minutes, domain is time. So t greater than or equal to 0, less than or equal to. Remember, we need seconds. 16 minutes. We need to change it into seconds. So times 60. 960 seconds. E. For exactly one ride on the Ferris wheel, find an appropriate range for h of t. Range means height. The minimum height for this wheel 2.05 meters. Maximum height it's here 70.5 diameter plus 2.05 equals 72.55. So h of t greater than or equal to 2.05, less than or equal to 72.55. Let's go to F. Big text is a 17.2 meter tall cowboy statue that stands on the horizontal ground next to the Ferris wheel. By considering the graph of h of t, determine the length of time during one revolution of the Ferris wheel for which the chair is higher than the cowboy statue. Since we already figured out A, B, C, we can get a function h of t equals negative 35.25 cosine 4.5t plus 37.3. We will set up the inequality h of t greater than 17.2. We need to solve this inequality by graphing. We graph this function into calculator. We need to think about the window. X minimum is 0. X maximum will be period. Period we already figured out is 80. Scale. We will use X minimum or X maximum divided by 10. We use 80 divided by 10. For the Y minimum from 0, Y maximum, we know the maximum value is 72.55. We can use 80 or 90 or 100. It's really up to you. Let's use 100 here. Then Y scale equals 10. Let's go to graph on scratch pad. Put h of t into f1 of x. Make sure you change variable t into x. After we put h of t into f1 of x, then enter. Menu 4 to change the window. 0, 80, 8, 0, 100, 10. Enter. Then go to tab. F2 of x, we put 17.2. Then enter. We need to figure out these two intersections. Menu 6, 4. Menu 6, 4 again. To get this intersection. Let me show the work nicely here. H of t greater than 17.2. By graphing, T1 equals 12.2744. T2 equals 67.7256. The length of time delta t equals T2 minus T1 equals 55.5 seconds. Let's go to J. There is a plan to relocate the Ferris wheel onto a taller platform, which will increase the maximum height of the Ferris wheel to 85 meters. This will change the value of one parameter A, B, or C found in part A and B. Identify which parameter will change. We do know A is the amplitude, means the radius of the wheel. Radius of wheel won't change, so A won't change. For B, it's dealing with the period. We only increase the platform. A won't change the period, so A and B won't be changed. Only C will change. Find the new value of the parameter identified in part G. So this new C, that means the new midline. We do know the maximum height will be 85 meters. So 85 meters minus radius of this wheel or amplitude is 35.25. So say midline equals 85 minus 35.25 equals 49.75 meters.